All right, I am taping. Good morning. Today is day 39, which means tomorrow the class is officially 1/2 over. All right, tomorrow will be day 40 of 80. So today, as it says, we're going to cover chapter 3 of the Murach JavaScript jQuery text rather, and the rest of the period will be lab. Again, I envision this being taking till no longer than tomorrow over 2 and 3 labs and homework examples as a class. I will show you basically those at the end of the period today. And again, the rest of the period will be lab. Friday will be an entire lab period. Next Monday will be the pretest. I should tell you right now, when you get this pretest, please don't let it throw you. It's actually, in my opinion, much harder than the test is. In fact, I'm going to go out on a limb and say this. Probably those of you who have gone through the C# class be able to do this test in less than an hour. And those of you who have, if this is your first programming language, my guess is it still will only take you around an hour. But that's okay. You get the entire period. And as always, it will be due, at 11:59 or right at midnight on Tuesday of next week. All right. So we'll do the pretest on Monday, and then I'll go over it. So I'll give you time. I've actually got it done already, but I'll basically pass it out or email it to you on Friday. And then you will have an hour and a half to write it up, or if you do it on the weekend, or if you want to. So, and then I will go over it from 9:30 until 11 o'clock. And then, as it says, Tuesday then will be the actual test. Just so you know, now next week, I'm going to do this a little bit different, and I'll explain that to you when I want to go into the book in just a minute. So remember, your Bootstrap test is due tonight if you have not turned it in by midnight tonight. Your updated HTML, CSS chapters 11 through 15 work, written tests and or labs and or homework is due by 8 a.m. Sunday. All right, I want to grade it on Sunday, and that's why I'm making it 8 a.m. I want all this stuff. I want to put to rest everything that we've done with HTML, CSS, and Bootstrap by that time. And your JavaScript chapters 1 through 3 homework will be due a week from Sunday. All right, so with all that said, let me first start by going here and just mentioning so far, and you know this already, we went through on Monday, we went through chapter 1, which is our introduction to web development. We went through chapter 2 yesterday, get started fast with JavaScript. Today, we're going to go over chapter 3, the essential JavaScript statements. You already heard next Monday will be a pretest, Tuesday will be the hands-on test. What I'm planning on doing on Wednesday is to go over probably at least both chapters 4 and 5. All right. 5 is a short chapter. It's on testing and debugging. Rather than going on until 6, I'm going to skip 6 we are going to go over it. But next week, I plan on going over chapters 4, 5, and 7. All right. 6, I want to give more time to. It's not that it's a long chapter, but the DOM is amongst the hardest things that you have to figure out in JavaScript. So again, 1, 2, and 3 this week, 4, 5, and 7 next week. The following week will all be on chapter 6. Then we'll jump into the jQuery stuff. All right, so with that said, let's just jump into chapter 3. Now again, and I mentioned this, Grant, to you and to the other people in this class who have already taken the C# class. All right, you're going to learn in here that not everything, but almost everything that you learn in C# will apply, and it'll be done almost the same way when we get into doing this for JavaScript. All right, so in here we'll talk relational operators, logical operators, if statements, while loops, do loops, and for loops. Now, one thing they don't discuss until later in the book, and I don't understand why, is the switch statement. The switch is another way of writing an if. for those of you who don't, know much programmatically. So I'm going to actually introduce it in this chapter. Now, with that said, since it's not in this chapter as some of the stuff that's in here, I would never test you on it right now. So you will be tested on it, but not in your first test. It'll be in a later test. All right. After that, we will go through the 3 illustrative applications. I think I mentioned this yesterday. In fact, I know I did in the email I sent out. But what I'm doing now is out on GitHub. I've got a repo out there that's called JS Murach right here. And what's in it right now are the completed examples that we redid for chapter 1 with that email list, and what we did yesterday, the examples of what was it? It was the miles per gallon app and the test scores app. Well, in chapter 3 that we're in right now, what we look at is an enhanced miles per gallon app, and much of it is what I've already mentioned to you yesterday. Same with the enhanced test scores app. The future value thing is new. We'll talk about it when we get to that point. All right. And with arrays, I'm going to give you my own take on arrays. So I don't know, maybe we'll go past 10 o'clock today. I have a hard time imagining that, but you never know. This is not a super long chapter. It's only about 25 pages long. All right. So with that said, notice they first start talking about conditional expressions. And what a conditional expression is in any programming language is something that evaluates to true or to false based on you comparing something. I don't disagree with what they say, but let's keep it as simple as possible. You can do this with if statements, you can do this with switch statements, you can do this with the different looping statements. All right. And typically when you do this, as they mentioned right there, you end up using one or more of the relational operators. And the relational operators are shown here. Now, for some reason, okay, there's actually 2 more of them that are not shown here. I mentioned yesterday that not only is there an equals equals operator, but there is a triple equals operator, which really the name is identity and equal to. And since there's an equal equal operator, there is an exclamation point equal equal operator as well. For now, let's just concentrate on the 6 that are shown here. So when you want to check to see if something is equal to something else, you don't use a single equal sign, you use a double equal sign. If you want to check for inequality, it's the exclamation point followed by the equal sign. That's the way it's done in most programming languages. All right. Sometimes when you're writing certain kinds of programming languages or other things, there's other ways of writing an inequality. Sometimes you'll see a greater than sign followed by a less than sign. That doesn't work in JavaScript. All right, so equal, not equal, greater than or equal to, less than or equal to. And hopefully when you take a look at the examples that are in here, they just make sense. All right. Now, normally what you're going to see in here is not a statement like the ones that are shown, but it'll say if, and then in parentheses, last name equal Hopper, or if, then in parentheses, test score equal 10, etc. That's the way you'll normally see them. All right. Then for whatever reason, right now, they also bring up is NaN, because you can use that also with these things. All right. So this should make sense to you. Is NaN, all right, with Hopper is going to return true because that's not a number. Is NaN, now notice what they put in here is something in double quotes. But since everything that's in there represents either a numerical value, in other words, a number between 0 and 9, or a decimal point, all right, it comes back as false, all right, is not a number, because it really is a number. What they're saying there is it possible to take whatever that is in the parentheses And is it either a number or could it automatically be converted to a number? All right. Okay. So again, a conditional expression uses relational operators, and these are the 6 that we've been talking about. And the is NaN. This is important here, this note on the bottom of the page. All right. When you use just a single equal sign, that is not a test for equality. All right. Rather, that's assignment. And usually what's going to happen is, I believe that if we do it incorrectly, in other words, if we use a single equal sign where we should use a double equal sign, then what should happen is when you run the program, either it's not going to work, all right, or if you go into the console, it'll give you either an error or a warning. Now, what's weird is, just imagine for a second, I just want to show you something. If we had something like this, let's pretend for a minute that we said let age equal 21. We did that the other day. Now let's suppose that someplace later on in the program we incorrectly type in this: if age equal, let's just say, all right, believe it or not, that's true. That's not checking for equality. That's checking to see if we can assign the value 50 to the variable age, and you can. So you never want to, when you are checking something in an if statement, or as you'll see in just a few minutes, in a loop, you never want to use a straight equal sign when you're checking for equality. Not only that, as I mentioned to you yesterday, it's very rare today that you'll see the double equal sign that they're showing there. I don't know why they didn't show the triple equals, but they didn't. So we're going to look at both as we go on here. All right. All right, then there's logical operators. And I actually showed you a couple of these, or at least one of these yesterday. And they are and, or, and not. You don't use the words, but these are the words that they mean. So if you want to check to see if something and something, you use 2 ampersands. If you want to do something or something, you do 2 pipe signs. The pipe sign is right up above your enter key. So it's shift and then the key right above your enter key. And not is the exclamation point. Now, again, this is review for many of you, but if I do this, and let's just say here, let number 1 equal 27. Let number 2 equal 18. I'm just literally making this up right now. There's nothing big to this. All right. So if I come in here and I do this, if I say if number 1 is greater than 8, well, that's going to be true, right? That's going to be true. Also, if I were to come in and say, if number 1 is greater than or equal, or equal to 8, that would be true. If I'd say if number 1 is less than 8, or if I said less than or equal to 8, of course, these would both be false. And if I said if number 1 equal 8, what that would be, equal 8, that again would be false. And if I say if number 1 not equal to 8, that would of course be true. All right, now that's simple because I'm only comparing one value to a number. Well, let's come in here and change all these number 8s here. Let's change all of them to number 2. All right. Is 27 greater than 18? Yes. Is 27 less than or equal to 18? Or sorry, greater than or equal to 18? Yes. Is 27 less than 18? No. Is 27 less than or equal to 18? No. Is 27 equal to 18? No. Is 27 not equal to 18? Yes. All right. So that's, again, pretty simple stuff because I'm only doing a direct comparison between two values. All right. Now, what if I want to do this? What if I've got here, let's just suppose as an example, I've got here, let magic number equal, I don't know, 22. Okay. And now if I come in here and I say if, and I can check both of them, if number one, oops, is greater than or equal to magic number, and number two is greater than or equal to magic number. All right. Well, when with an and, both sides of the equation have to be true. All right. So it'll check and it says, is number one, which is 27, is it greater than or equal to magic number? It is, because 27 is greater than or equal to 22. So it'll check the other side. All right. And now it says, is number two, which is 18, is that greater than or equal to 22? It's not. All right. So when you think about it, if we're comparing two different things like this, what we can have is the first one can be true and the second one can be true. All right. Or the first one can be true, and the second one can be false, or the first one can be false and the second one can be true, or the first one can be false and the second one can be false. All right. The only time this kind of a condition with and is going to be true is if both portions are true. If one part is true and the other part is false, it's automatically false, because and means both sides must be true. Not only that, the way that JavaScript works, it's the same way that C# works. And what I mean is, for these two cases that you see down here, all right, JavaScript uses what's called short circuiting. What that means is, okay, if we come here, if this, let's suppose, for example, that this magic number was 32. All right. So it says if number one is greater than or equal to magic number. Well, is 27 greater than or equal to 32? It's not. Since this is false, there's no sense in checking this. There's no sense in doing that. The first part is already false, so you don't check the second part. All right. So again, if the first thing is there is true and the second thing there is true, then the whole thing is true. Otherwise, it's false. And you can keep that in mind. All right, because in just a second, we're going to check out the or. All right, but that's the way it is. And that's how computers are wired to do a lot of the things that they do. In fact, and you probably don't care, but I'm just going to bore you with a very quick story. Then when I was working on my master's degree, I took a class in computer architecture because I wanted to see internally how computers worked. And they gave us this little simulated computer. I'm dating myself by using this term, but it was called a Heath kit. And what we had to do was to sit and literally wire up. So literally using wires, we had to wire up what was called AND gate, or what was called an OR gate, or what was called a NOT gate, and come up with situations like this to prove that they were correct. But internally, that's what happens in the computer. All right. So let me remove this. All right. And I'm going to move that up. Now I'm going to grab every bit of this. I'll keep that one there, but I'm going to change all of these from an and to an or. And we're going to set this back again to 22. All right. Now, when you work with an or, what's going to change here is this is true. Whoops. And this is true. So in many ways, they're kind of inverses of one another, in that when you do an and, The only time an and is true is when both sides of the equation are true. But when you do an or, the only time an or is false is if both sides there are false. Okay? And again, just like I mentioned before, when the system does checks like this, it does short circuiting. So as soon as with an or statement like this, as soon as it comes back and it says, oh, number one is greater than the magic number, it doesn't check the second one because there's no sense in doing it. Since it's an or, only one half has to be true. Just like when it's an and, all right, only one half has to be false. Now, I'm giving you very simple examples, but you could have if this and this, or this and this, or this. This can be as complex as you want it or need it to be, just so you're aware of that. All right. So again, now sometimes people say, well, I want to make both checks anyway. Even if the first one is false, I want to check the second one anyway. You can actually do that by using just a single one of these or a single one of those. It's very fun, but there's nothing that prohibits you from doing that if you want to. I don't know the value of doing it. I really don't know. All right. The other one that's there is not. All right. Now, how do we change that? Okay. Well, remember earlier we had this stuff in here. So we had if number one greater than or equal to number two. All right. Number two. All right. And you saw this already. Okay. Number one is greater than or equal to number two. All right. But we could even come in here and say, if not, and that would invert it. All right. So that would be false because what the exclamation point does is it's an inverter. It takes something that's true and it makes it false. It takes something that's false and it makes it true. All right. And one more thing I want to say about this. All right. And that is, I'm going to just come in here and make one more variable. All right. Hopefully all of this stuff in here made at least some sense. Not to you so much, Grant, but to the people who have never seen this before. But I'm going to have one more variable and I'm going to call it let is married, and I'm going to set it equal to true. All right. That's a Boolean variable because its values, possible values are true and false. Now, if down here I'm checking and I say if is married, that's a shortcut for saying if is married equal true. Now, if that confuses you, that these mean the same thing, then don't use this one. When you're in your first year of programming, I'm looking for understandability. All right. I mean, ability as well. I want you to be able to do this stuff, but I want you to understand what you're doing. All right. So this is just a shortcut for this. And in the same way, this is a shortcut for, all right. And I will tell you that, if you were working professionally as a programmer, you'll never see this. You'll always see this. You'll never see this. You'll always see that. All right. All right. But I mean, all I'm trying to do is to give you a couple of examples. All right. You get a lot more looking in the book, but sometimes people get a little bit confused, you know, or they don't like the example. So I tried to give you something that was, I thought at least, really simplistic. All right. So the other thing that's in here, when you look right under example 3, it's the order of precedence. What does that mean? That means if you've got a program that uses an exclamation point for not, and a double ampersand for and a double pipe sign for or, unless you use parentheses, all right, around one or more of them, you always do the not first, then you do the and second, then you do the or third. And the reason for that is the not is an inverter. It's going to take something that was true and make it false. All right. That's the most restrictive operator. The next most restrictive operator is the and, because again, as we already looked at, both sides had to be true when you were comparing two things, or the whole thing was false. Or is the least restrictive operator because it only needed one side to be true. All right. So that's why the order of precedence is set in that way. And again, as they say, to clarify or change it, you can use parentheses. All right. Now, let's talk about the basic control statements. Okay. And I have talked about this kind of thing before, and I'm going to make this really, really simplistic here. All right. So I'm going to bring this up on the screen here. And I'm just trying to do this for clarity's sake. Okay. So you're going down the road. And let's do it like that. So that's you and you're driving down the road. All of a sudden, the road ends. All right. The road literally stops. And you must either make, from that point of view, kind of a right turn. All right. Or you must make a left turn. All right. I guess I should move that over a little, but you get the idea, hopefully. All right. So you're coming down and you this way, or you've got to go this way. All right. And you can't, let's assume it's a one-way street. So you can't back up. You can't just stop. You've got to go one way or the other. Right. That's a typical if-else statement. So let's think about how that would be. All right. Let's assume that we come in here and let's assume we set a constant. And we're going to call this voting age. And we're going to set that equal to 18. All right. So then we come in and we ask somebody their age. So I'm going to say, let age equal, we did this the other day, and we're going to say parse int prompt, what is your age? All right. And we're going to assume that it's, let's say 21. We'll give that as a default value. So what's going to happen is when you run this, it's going to come up and it's going to show a prompt statement that's going to say, what is your age? And in the box right there will be 21. All right. Well, we can come in here and say, if age is greater than or equal to voting age, all right, we're just going to make this real simple. We're not checking in here like we did yesterday and validating that the age was a number. We could go in and do all that stuff. All right. So again, we could, in fact, let's just do it for completeness sake. So we can come in here and go in here and say, while is NaN age, or age is let's see if it's not a number, or it's less than or equal to 0. You can't be 0. Or let's just assume that the oldest person we know of is 125 years old. All right. So if we do that, that's basically making checks. In other words, range checks and reasonable checks. So if any of those are true, we'll just say, ask them again. All right. So then once we're stuck in that loop, we're going to talk more about loops in just a bit, but we're stuck in that loop until they put in something that's numeric and is between 1 and 125. All right. So we can say if they put in a number that's greater than or equal to 18, we're just going to say an alert, hello, you can vote. Okay. All right, and then we'll say else alert, sorry, you are too young to vote. All right. And if you understand that, if you do understand that, there's not a whole heck of a lot more to this. All right. So again, we are prompting the user for their age. If they put in something that's not a number or something that's out of range, right, we ask them to do it again. So they'll be stuck in here until they put in a number between 1 and 125. Then we're going to check that number. If that number is greater than or equal to 18, we'll give them this message. Otherwise, we'll give them this message. Now, a couple more things on this. First of all, what if I left this off? All right. I said you're 18. It won't give you an alert. It won't say anything. All right. So you can have an if all by itself, or you can have an if else. And there's also another one that you can have. So let me put this one back. I'm going to actually put it in here twice, but I'm going to modify it after I do. All right. I'm going to say else if age equal the voting. So if you're 18, I'm going to say just made it. You can vote. Now there's three possibilities. All right. Either, all right, in fact, I'll let, yeah, we can still do it like this. But the problem is, as soon as it finds this one's never going to get hit. Because if you are 18, you are greater than or equal to 18, so it's going to say this. So to make this one so it would run, I'll change this one like this. I'll say if you're less than the voting age, we'll put this one back in here. All right. And then, so we'll do it like this. In fact, move that over and do it like this. So now you'll have an age. If the age is less than 18, it'll come back and say, sorry, you are too young to vote. Otherwise, it'll check to see if you are 18. It'll say, just made it, you can vote. Otherwise, all right, otherwise, it'll just say, hello, you can vote. So what I'm telling you is, this will handle, I'm going to write a comment here, handles all ages between 1 and 17. All right. This handles only age 18. And finally, this handles ages 19 to 125. And again, if you can understand that, you understand the basis of how if statements work. Not only an if, but an if with an else if, or just an if with an else. You can have as many else ifs as you need to have. So if, like, for instance, what if I, let's take this down and let's keep working on this example here. Not the example, but let's keep working here. And what I'm going to do is I'm going to steal a little bit of the code that's in here because it'll make it easier. All right. So let me come in here and do another example. All right. So I'm going to come in here and I'm going to say const, and I'll do it like this: min test score. We kind of did this one yesterday, but it's okay. And we'll make that 0. Const max test score, and we'll make that 100. We're assuming that the lowest grade you can get, you did none of the test, you got it all wrong, or you didn't take it, was a 0. You got everything right, it's 100. All right. So here we're going to say, let score equal parse int prompt. What was your score? And again, we'll just give it a value. Let's just say we'll give it 80 as a default. All right. So while we put something non-numeric in for score, or the score was less than our min test score, or our score was greater than our max test score. So if that happens, we're just going to ask them to do it again. Okay. Again, very similar to the examples we looked at yesterday. Now, what we want to do is we want to figure out what their grade was. Okay. I'm first going to show you this, and I'm going to show you the foolish way of doing it. And then I'll show you a better way of doing it. Now, we're going to assume here, so I'm going to write this down as a comment. We're going to assume that 90 to 100 equals an A, 80 to 89 equals a B, 70 to 79 equals a C, 60 to 69 equals a D, and less than 60 equals an F. All right. Now, that's not exactly the way Rankin's grading system works, but to keep it simple, that's the way we're going to do it. So once we get down to here, we know we put in a number, and we know that number must be between 0 and 100, because if it's not, we're going to keep them in this loop. All right. So I can say here, if score, two of them in here, if the score is greater than or equal to 90 and the score is less than or equal to 100. In fact, we don't want to use, we'll use 90, but instead of 100, we'll put max test score. Max test score. If that's the case, all right, then we're going to just come in here and say letter grade equal A. All right, now we don't have a variable called letter grade, so let's create one. We'll just say right here, letter grade, let letter grade equal, and I don't want it to be equal to anything, so I made it equal to the empty string. All right, so that'll handle A's. Okay, and what I'm going to do, just to try to make it a little easier, is I'm going to do a bunch of copying here. All right, so we can say if it was between 90 and 100, it's an A. Otherwise, if it's greater than or equal to 80, and it's less than or equal to 89, it's a B. We're going to rate this in a little bit better way in just a second. Otherwise, if it's greater than or equal to 70, and it's less than or equal to 79, it's a C. Otherwise, if it's greater than or equal to 60, and it's less than or equal to 69, it's a D. Otherwise, in fact, all of these should be else ifs, else if, else if, else if. And I could make that an else if, but this should be okay just being an else. Else the letter grade is an F. And then we could do an alert. All right. And we'll use the template literals like we did yesterday. Your letter grade is, and we'll put inside of here, letter grade. Now, I'm not actually writing this, so is it possible that I made some errors in here, etc.? Yes, I don't think I have. But there's a reason I'm showing you an example like this. All right. The way that an if actually works is it keeps going and going and going And it does that until it finds a match. And as soon as it finds a match, it jumps out of where it is. And if you say, I don't understand, actually, I think you do. All right. So let's just take a look at what's in here. I'm going to trying to make this smaller. Let's make it about 18 should do it. That may be the 20 will. Yeah, that'll work. All right. So let's assume for a second that the grade was a 93. All right. Is 93 greater than or equal to 90 and less than 100? Yes, it is. So we do this. We set letter grade equal to A and we skip all of these. We do it again and they got an 83. So is 83 greater than or equal to 90? It's not. So since it's an and, we don't have to check this other half. So we come down to here. Is 83 greater than or equal to 80? Yes, it is. So it's a B. We do it again and we put in 73. Is that greater than or equal to 90? No. Is that greater than or equal to 80? No. Is that greater than or equal to 70? Yes. And it's an and, so we have to check, is 73 less than or equal to 79? Yes, it is. So it's a C. We do it again and we put in 63. That fails, that fails, that fails. 63 is greater than or equal to 60, and it's less than or equal to 69. So it's a D. We do it again with a 53. That fails, that fails, that fails, that fails. So we get to the default case, which is an F. All right. Now, there isn't anything wrong with doing it this way. Just so you know, there's nothing wrong with doing it this way, but we can make it even simpler. And what I mean is this. I'm going to change this so it looks just like this. I'm going to change this so that it looks just like this, and this so it looks just like this. Now, when we come in here, all right, we have to still check at the beginning to make sure. In fact, technically, we don't even need this check to see if it's less than or equal to, because if we put in a number that was actually greater than 100, it's going to be caught in here. So we don't need this either. So we can say if the score was greater than or equal to 90, it's an A. Now, if we get down to here, you can say, well, wait a minute, like what if they got a 93? Well, remember, if they got a 93, we already set it equal to A and we jumped out of the loop. All right, we're already out. So if we get down to here, the score has to be at least an 89. If we get down to here, the score has to be at least a 79. If we get down to here, the score has to be at least, or not at least, but between 60 and 69. When you are coding, the idea is, why make the computer do more work? All right, it's like, if you go out to your car, all right, you're not sure if you left your lights on. All right, so you look out the window and you see the lights aren't on, but you walk out there and you check anyway. I mean, was it really worth doing that? I don't know. Personally, I would think not. All right. And that's, same kind of thing with the lights in your house or whatever. So what I'm trying to show you, what I'm trying to get across here is an if keeps going until it finds a match. When it finds that match, it executes the code that's in there and boom, it jumps out. So if our grade was a 93, we do this and every single bit of this is skipped. It'll go right down and say your letter grade is A. All right. And if you can understand that, that's pretty much, all right, what there is about an if statement. There's really not a lot more to add in there. You can go ahead and read this on how to code it. You can go ahead and read their examples, and maybe you think their examples are better than mine. Totally fine. All right. But I'm trying to show these again to you in what I consider to be the most straightforward way possible. All right. Now, it says an if statement always has one if. It can have one or more else ifs, and it can have exactly one else or zero elses. All right. If it's just an if, it's called an if statement. If it's an if with just an else, it's an if else statement. If it has one or more else ifs, it's an else if statement. If there's an else on the end of that, it's an if else if end. I should say an if else statement. All right. Most people just call it an if statement regardless. Okay. All right. Now, before we go into loops, no, we're not going to take our break quite yet, but I want to say one more thing to you. I want to show you something. All right. I'm going to look at one more example that I'm going to put in here. All right. And that is, I'm going to come in and just so you can see this. And again, as I mentioned previously, this would not be on your first test. I guarantee it. But I'm going to come in here and do this. I'm going to say, let size equal, and I'm going to put just a prompt, no number, and I'm going to say, please enter your size. And I'm going to assume that your size is either a small, a medium, a large, extra large. Those are the only four. There could be more than that. I don't care. And we're going to assume that it's a small. I'm just making this all up right now. All right. So it's a simple prompt like that. Okay. Now, in here, since it's just a prompt, we don't have to validate it. Okay. We will later, you'll learn how to use things where you can run something that if you put in a lowercase s, it'll convert it. We're not going to worry about that for now. But I'm going to say this. I'm going to come in here and say if size equal s, I'm going to put in a statement here that says alert, you are a small. All right. Again, this isn't really like, oh, wow, gee whiz type of thing, but I'm going to put all these in there. So we've got a small, we'll have a medium, a large, an extra large, and we'll even have a thing at the bottom. All right. And again, I'm going to make this a little bit smaller so you can see small, medium, large. Okay. I'm going to make it a little smaller so that you can see everything in here. All right. There. All right. So if it's S, it's a small. Else, if it's an M, you're a medium. All right. Else, if it's an L, you're a large. Else, if it's an XL, you are an extra large. Otherwise, so it'll be else here, and it's going to say size unknown. Now, if you can understand this, all right, then you've got a really good understanding of being able to use an if statement. Previously, we were checking numeric values, and that's a lot of times where this is going to be used. But I wanted to show you here, all right, technically, when you think about it, there were really 101 possible grades that a person could get. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 100. But in this example, there's only 4 valid sizes, and they are S, M, L, and XL. And if you have anything other than an S, M, L, or XL, we're just using down here kind of like a default that says size unknown. So why am I even showing you this? I'm going to leave this here, and I'm going to write the equivalent of this over here on the right so you can see both of them. I'm going to type in here switch size like that. Then on the next line, I'm going to put in a curly brace. All right. And then I'm going to start putting in here. So case S, and I'll put the same alert in here that we had right there. So we're going to say that. And then underneath that, we're going to say break. All right. Then I'm just going to keep going here. Okay. So case M, you are a medium. And again, we will put in here break. Oops. Then next, case L, you are a large. And again, a break. And finally, well, not finally, because we have an extra large and then a default. Case XL, you are an extra large. And whoops, sorry. And break. Finally, use the word default. And we put in here alert, and we said size unknown. All right. And then break. And finally, and they're curly. So these two things are doing the exact same thing. All right. I'm going to leave these up there. All right. But just so you know, they're doing the exact same thing. Now, they look different, of course. All right. But the case S is the same thing as saying if size equal S. So if that's true, you do this. But then notice we've got the word break in here, and I didn't need those semicolons. All right. Again, we could, but we don't need them. Break means it's the same thing as like with an if that says get out and don't do the rest. If we did not put the word break in here, so let's say we left off every one of these break statements and it asked our size and we put in an S, it would come in and it would do this. It would say, alert, you're a small. Then it would jump right down here and alert, you're a medium. Then it would jump down here and say, alert, you're a large. It would jump down here and say, alert, you're an extra large. And finally, it would say size unknown. It would do all of them because the break is used to get you out of a switch statement. All right. Because it's not smart enough to get out without it. All right. Now, two more things I want to say, then we're taking a break. The first is, like in this if statement that we have right here, when we only have one line, it's not mandatory that you put the curly braces in. I advocate always using the curly braces, even if it's only one line. To me, it makes your code more readable. Sometimes what you'll see too is the person with this beginning curly brace, they'll put it here. And where they have the else if, they'll move that up right after the ending one. There's a lot of different ways of writing this, is what I'm getting to. Finally, the last thing I want to tell you before we take our break is this. If you remember the example, well, did I get rid of it already? I must have. The other example that we had in here, I guess we had it over here. When we did this one with scores, you don't ever want to do that with a switch statement. We wanted to we would have to do a switch on the score. We'd have to say case 90, case 91, case 92, case 93, case 94, all the way up to 100, then letter grade equal a break. So we'd have to write, literally, we would have to write all the way up until we got to 60. Then we could, under default, we could just say the grade was an F. But the only time you really want to use a switch, all right, is when you have a finite number of cases. Finite meaning, and again, there's nothing wrong with either one of these. They both would work just fine. They're both acceptable. There's nothing wrong with either one of them. All right. And again, all I'm trying to do is just to show you some different ways of doing the same thing. And what I is I'm going to come back to here. We're going to take a break in a second. And I'm going to grab this and I'm going to actually put it on the top here. Okay. And then what I will do is at the end of the day today, I will just put this in there as another file. So if anybody has any desire to see it, or if you forget how to do something, etc. And when I come in here, I'll put in some, whoops, not that. I'll put in some kind of a, geez Louise, Jeff. I'll put in some kind of delimiter in here. All right, some kind of a, um, I'll do it during the break. I'll put some comments in there so you know what's going on. All right, it is 9:01. Let's take, let's make it 9:12 that we'll come back and we'll pick it up and start going over loops. All right. All right, it is 12 minutes after, so we're going to pick it up, and there's about 4 more things I want to do in this chapter. First, we're going to discuss the 3 loops, as you can see right here. After we do that, we're going to look at the first 3 examples that they gave in the chapter, and that is the miles per gallon program, the test scores program, and a future value program. Then we will talk about arrays for a little bit and look at the associated array program. And finally, I will bring up the homework and the labs that you're going to have for chapters 1, 2, and 3. And we can look at what we'll be working on from there tomorrow. All right. So this is real simple. And all we want to do here is we want to print out the numbers from 1 to 10. That's all we want to do. So ideally, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just like that. Now, ours is going to be a little different because we're going to use alerts. We could use it. In fact, we can use a document.write on the screen. We could do that just as well. So that's what we want. I'm going to get rid of that because hopefully that just makes sense. I'm going to show this to you doing it 3 different ways. Now we could just do it, say document.write 1, document.write 2, document.write 3. We could do it like that. And there'd be 10 lines of code. What if I told you to go to 100? Well, then it would take longer. What if it was 1,000,000, etc.? So you wouldn't typically do it that way. All right. So what you have to do when you are working with a loop is you use what's called a loop control variable. I have a tendency to call my loop control variables LCV, for loop control variable. So I'm going to come in here and I'm going to do this. I'm going to say let LCV equal 1 while LCV is less than or equal to 10. Document.write LCV plus plus, and that's it. Now, there's a lot of stuff going on here, so let's talk about it. All right. When you work with a looping condition like this, and we're going to look at this with all 3 of these conditions. All right. The first thing we're doing here is we are initializing the loop control variable. And again, I just call mine LCV. This is one time it's considered okay to just call this X, for example, or call it I or whatever. Sometimes people call it count or counter. Again, I call mine LCV. So the 3 steps are, number 1, you're initializing. Number 2, you are testing the loop control variable value. And finally, the last one is number 3 here. You have to change the loop control variable value. If we left this statement off, if for some reason that would be unbelievably foolish, because what would happen is it would just keep writing on the screen 1, 1, 1, 1, 1, 1, 1, 1. It would be in what's called an infinite loop. So it comes through here, and we've set LCV equal to 1. Then it checks, is LCV less than or equal to 10? Well, 1 is less than or equal to 10, so it value. And then it adds 1 to it, meaning it's now 2. Then it jumps back up to the top, and it says, is 2 less than or equal to 10? It is, so it writes 2, it adds 1 to it, it keeps going. Finally, it says it's 9. So it prints out 9. It adds 1 to it. Then it's 10. Is 10 less than or equal to 10? Yes. So it writes 10. It adds 1 to it. Comes back up. Is 11 less than or equal to 10? No. So it drops out of the loop. All right. Now, when you work with a while loop like this is called a pretest loop. You check the value of your loop control variable before you get into the body of the loop. What does that mean? That means if I make this For example, if I said while LCV, let's do it this way. If I made this 11, 11 is not less than or equal to 10. So it would totally, this would fail. So you'd go right down to here. So again, this is called a pretest loop because you make the test before you get into the body of the loop. And with all three of these loops that we're going to look at right now, because in just a second, I'm going to rewrite this as a do-while loop. All right, with all three of these, they involve initializing a loop control variable, testing a loop control variable, and changing a loop control variable. So that's the first one for a while loop. Let's go and rewrite this, and we'll rewrite it as a do-while loop. So again, I'm going to, I'll just come here and just, put something in between here. All right. And I'm going to grab this because it's going to look very similar, yet it'll look different. All right. So I'm going to let it here, but now I'm going to grab this thing. And I'm going to type in here the word do. All right. And then down here at the bottom, I'm going to put this in. This is the only time that if you put in semicolons, it is legal to put in a semicolon here. You never put in a semicolon after an if. You never do that. You never put a semicolon in after an else if or after an else, etc. You never do that. In fact, that should have said else down here. And that should have said else here too. All right. So you never do that. All right. But if you use a do while, it's acceptable to put that in here. So what's the difference here? Well, I told you before, this was called a pretest loop. This is called a post-test loop, meaning you always go through the loop at least one time, even if this had been 11. Remember, if that was 11, we would have skipped it. But with this being 11, we write out 11, we add 1 to it, meaning it's 12. 12 is not less than or equal to 10, so we jump out. All right. So if the goal of your code is to make sure that the body of the loop is always at least one time, that the body of the loop is always executed, all right, then you typically use a do while loop. Anything you do with a do while, you can do with a while loop. All right. But if you want to make sure that the body of your loop is at least one time, if you want to make sure it is executed, you use a do while loop. But you'll notice here we're doing it in order 1, 2, 3. Here we're doing it in order 1, 3, 2, because the order is initialize, test, change. And we could go backwards from this too. So in other words, we could use a minus here. What if we were doing something where we were simulating a rocket taking off? We could start with 10 and say while it's less than or equal to 1, all right, and we could write it out into a minus, and then when we got done, we could say blast off, for example. All right. So there's, again, always a lot of ways you can do this. But again, this is a pretest loop, because the testing is made before you go into the body. This is a post-test loop because the testing isn't made until after you've executed the body at least once. All right. Then there is a third one. So let's take a quick look at that. The third way of doing this is a for loop. Like the while loop that we saw when we started, the for loop is called a pretest loop. But you do everything inside of the same statement. So let me grab the body here. Just this, I'll grab all of this because I'll have to drop a little bit of it, but that's okay. So I'll come in here and say for LCV equals 0, LCV less than or equal to 10, plus LCV. Here we have to put in the semicolons. Now let me grab this and I don't need that while that's in here anymore. All right. But what are we doing? Well, I don't need that either. In this statement right here, we are initializing the loop control variable, testing the loop control variable, and changing the loop control variable. So you can results in less code to use a for loop. A for loop is also known as a counting loop because you need to know with a for loop exactly how many times you're going through it. All right. So let's say that I work for an insurance company and I I have, or even better, a bank, and I want to do something with deposits and withdrawals. How many do I have? I don't know. Either I'd have to count them first or run them through a program to count them first, or I'd have to use a while loop or a do while loop. Unless I know exactly how many of those I'd have, I couldn't use a for loop. All right. So keep that in mind because that's my introduction to this. All right. And again, if you think that the way they're doing it in the book is better, then just keep on reading the book. All right. But part of the reason that I do it like this is I know, a lot of people will tell me after they take this class, yeah, I didn't really even read the book. I didn't like the book or whatever. So at least I'm giving you some examples. All right. Notice their example here with a while loop right here. You can combine all the stuff we've used so far. Is NaN or less than or equal to? Totally fine. Whether you're using a do loop or whether you're using a while loop, all right, or whether you're using a for loop, all right? So as it says here, the while statement creates a while loop that contains a block of code executed as long as your condition is true. It's tested at the top and it's skipped or you're done if the condition is false. If the condition is false to begin with, you never go through the loop body. And that's also again known as a pretest loop. The do while, which is a post-test loop, all right, its condition, as it says, is tested at the end. So you are 100% guaranteed that the loop body will execute at least once. All right. If you don't change the value of your loop control variable in any of these loops, you are creating what's known as an infinite loop condition. All right. If that does happen to you when the program's running, typically, if you do hold down on their control key, which is in the lower left corner of the keyboard, you do a control and then find the break key, which is up somewhere in the upper right hand. Will get you out. If it is, you got to turn the computer off. All right. So they give you examples of all of them, including a for loop in here. All righty. And again, there are so many different ways of writing these things. All right. When I say there's three, yeah, there's three ways, but there's some offshoots and there's things to know, etc. And a lot of them will make more sense after we've used them for a while. All right. So it says here, the three applications that follow illustrate the use of these control statements we've been talking about. All right. Now, notice what we have here. It says first we'll have the enhanced miles per gallon or the enhanced MPG. I've already got it up. You don't see it on screen now, but I've already got it up inside of Visual Studio Code. So we're going to look at it in just a minute. All right. So what they're doing in here is they're going to allow you to run the program multiple times. All right. And it'll ask you if you want to run the program again. And if you say a Y for yes, it'll run it again. All right. They'll also do some validation in here to make sure that their gallons is greater than 0. So this is more in line with what we did when we started to make the changes. All right. So this is how it'll look. Not that much different, except for the fact that, again, we'll be able to run the program more than once. All right. And again, that's all they're putting in main. All right. And then, so they're putting the script tag right in main. All righty. And then this is all the code that they're putting in here for the actual file itself. All right. I'm going to make one little change on this in just a minute because I want you to see something. All right. So let's take a look at the code. Let's bring it up, and we'll bring it up right in Visual Studio Code. So this is the MPG program. Again, I'm going to quote fix, unquote it. All right, so I'm going to put a CSS folder in here. And in that CSS folder, I'm going to add a new file, which is my styles.css. And again, I'm just doing this. Why? Because it's good practice to do this. All right, and I'm putting that. Did it go in there? No. So I want to put this file in here. No, I'm not sure why it's not going in there, but we'll get it in there yet. There, we'll do it here. No, that's fine. We'll get it to work in just a second. And I'm going to make a JS folder. All right, do it over here then. Forget that. I don't want to waste my time or your time watching me fumble around here. So this is the MPG. All right, and I'm going to grab this CSS file and put it in the CSS folder. I'm going to make a JS folder, which I could have done earlier inside of code, and I'm going to move that file in here as well. All right, so now in my CSS folder, oh, okay, we don't need style CSS, so let's get rid of that. But I'm going to remove this. Okay, so we now have what I want, our index file, our CSS folder with, I don't know why that's in there, our CSS folder, and that CSS folder has our mpg.css, and a JS folder, which has our mpg.js. All right, now let's come back into here. All right, so there it is. So there's our CSS file there. There's our JS file. All right. We don't have to make any changes to our CSS file. I'm not going to go over it. Very similar to the examples we looked at yesterday. We are going to look at the JS in a minute, but before we do, let's make the two changes we have to make to our index file, and those are to give it the right path for our CSS file and give it the right path for our JavaScript file. All right. So the first thing I like to do when I move stuff around like that is to make sure I didn't break anything. So let's just run it. So enter miles driven, 444. Enter gallons used, 55. Repeat this, no. So we've got that. Okay, 8 miles a gallon, totally fine. All right, and I've got this blown up so it's a lot bigger than it would normally be. All right, so let's look at the actual JavaScript file in here. We can close both these and just open up our JavaScript file. All right, so we're doing that use strict. And again, remember that when we do this use strict, we're just telling JavaScript to be more conservative. In other words, if we just have a variable that appears out of nowhere, don't allow that to happen. Flag that and let us know that it's a problem. You'll notice in here, we've got a variable called again equal to y. All right, what does that mean? Well, if it asks us if we want to do it again and we type in an uppercase y, guess what? It's not going to let us do it again. I'm going to show you how to fix that in just a second. All right, and the whole thing is in a do while. Now, the only checks they're making in here are if miles is greater than 0 and gallons is greater than 0. This still, pardon my French, this sucks. These suck as tests. I'm going to leave it the way it is because they're using the if in here. All right. I don't know why they've got an extra space, but they do. All right. So if they're both okay, then you're doing your calculation and then you're displaying everything. That's it. Otherwise, you're going to come up and say one or both entries are invalid. Then you're saying, do you want to repeat it? Okay. Now, a couple things about repeating this. What if they put in an uppercase Y? If you wanted that to work as well, we could say this. We could say while again equals a lowercase y, or again equals an uppercase y. That's one way to make it better. All right, because now it'll take an uppercase y or a lowercase y. That's good. Now, what about the person who isn't really looking at the instructions and types in the word yes? All right, hopefully you're with me here. So they come in there and they type in yes. Well, right now it's not going to run again. So what I'm going to do is I'm going to add another variable up here that I'm going to call, oops. So and I'm going to just call it first char. So it's the first character in here. And I'm going to set it equal to nothing. It's nothing. Right now there's no value to it. But after you type in this, it's either going to say a Y or an N or whatever, but I'm going to come in here and do this. Okay. The first thing I'm going to do is I'm going to say again equals again dot to upper case. All right. What that's going to do is if I put something in lowercase, it's going to make it uppercase. So now I don't need this part anymore. All right. I only need to check and see whether or not it's equal to an uppercase Y. There's a two lowercase I could have used as well. All right. But the problem is if I type in the word yes, it's still not going to take it. So I'm going to say first char equals, oops, equals up again dot char at 0. So what that's doing is that's grabbing just the first character. And that's not chart at, it's char at. Now I can do this, but it's not going to be again. It's going to be first char. Now it'll handle anything that I type in when it says repeat entries. But the only thing it's going to grab from there, the only thing it will grab from there is the first character. And if it happens to be a letter, A through Z, it will uppercase it. All right. Let's see if what I did works or doesn't work. Probably when I save this, probably all of these semicolons are going to go away, but it's totally fine. All right. And they did. All right. So let's go ahead and run this. Again, I have to bring up the index.html. You can't run live server from a JS file. So I'm going to run it here. All right. Now, if I do put in something that's invalid, hello and 43, it does say one or more entries are invalid. Okay, so that's good. Do you want to run it again? Now, if I say yes, notice it runs it again. All right, so if I come in 456, 23, and do I want to run it again? No. Okay. Now, don't get me wrong. I'm not saying, yeah, I made this program so much better. What I'm doing is I'm showing you little extensions or little things we can add onto a program to make it better. Now, you might say, well, I don't think you made it better. Okay. But if we go back to the way it was, and like I said, if we leave it, so if we leave this the way it is, and we get rid of these two lines, I'm not going to. In fact, let's comment them out. All right. And we'll make this an uppercase Y. All right. And we'll say here we want you to type in an uppercase Y or an uppercase N, like that. All right. And I'm going to save this and I'm going to run it again. All right. And I'll say again, and it gives run it again. Now I'm just going to type in here yes. And notice it stops. All right. The computer is a dumb animal in that it only does what you tell it to do. All right. It's not taking any liberties here. So if I go back and change this to what we had before, now it's going to handle an uppercase Y, a lowercase y, the word yes, all of those. If I put yellow in there, it's only grabbing the first character and uppercasing it. So that will work as well. And as I mentioned, if you don't like this, okay, we could make a two lowercase too. If we made that two lowercase here, we would check for a lowercase y. So there's a lot of different ways around this. All right. Okay. So that's the first one. So file, save all. And I'm going to close this one down and go back into our book. The next program is a future value program. For whatever reason, the people who write books for Murach are infatuated with future value programs. Okay. What this says is if I invest $10,000 at 7.5% for 10 years, this is what I should have when I get done. And I believe that's the way it's run here. Now you'll notice what they have in here. They've got three do while loops in here, then a for loop. They are using those do while loops. All right. And when they're using those do while loops, they're doing that to make sure that you're putting in something that's numeric for the investment, for the years, and for the rate. Now, what they're not checking in here, so I'm going to add a little more to it, is you should check. We'll go back to this program and we'll make a minimum and a maximum investment amount. We'll make a minimum and a maximum rate, and we'll make a minimum and a maximum years. Because again, right now, you could come in here and put a negative amount in for any of these, and the program's still going to run. That's silly to do that. All right, but you could. All right. So we'll go in there and take a look at that as well. Now, this is just making sure you're putting in the numeric right there. That's making sure, that's making sure you're putting in a numeric here and a numeric there. All right. This is doing all the work. It's taking whatever your current future value was, multiplying it by the rate divided by 100. All right. And it's adding that back into future value. So that's the one. So I want to make sure I didn't break it. So we're going to start by putting in their numbers, 10,000, 7.5, and 10 years. And we're going to see if we get back 20,610.32. All right. So let's run that and see if indeed that's the case. All right. As always, and let me just do it here so I don't screw it up like I did before. So let's come in here. The MPG one is complete. So we're doing the future value one now. I'm going to come in here and add two folders. I'm going to add first a CSS folder, and next I'm going to come in and add a JS folder. And again, you don't have to do this. The programs work fine without them, but this is the way, as a programmer, you should be doing things. Why they do it like this, I don't really know, but they have. So I'm just going in and making my own changes. All right, so hopefully that did everything I wanted it to do. We'll jump back into here then. All right, so what do we have here? let me do this. I'm just going to reopen it inside of Visual Studio Code. So future value, open with code. There it is. So there's CSS with our future value CSS, JS with our future value, our index, which we will open up and just, again, change the paths. Okay, and save everything. And we're going to run this just as an initial run to make sure we didn't break anything. So we'll put in the 10,000, I think it was, the 7.5 and the 10 years. And yes, okay, so we didn't break anything. So there's a start. All right, so let's go in and make it, quote, better, unquote. So we'll bring up the future value. There's nothing wrong with what they have, but let's add a couple things. So let's add in here a constant, and we'll call it min investment. And we'll set that equal to, let's say you need to put in at least $1,000. And we'll put in a max investment. You don't have to do this, all right? But that'll be $1 million. So why? Or investment less than min investment. Let's put this over multiple lines so you can see it. And close this. Or investment greater than max investment. Okay, so if it has any of those, while it's not a number, etc., it'll come back and ask you to do it again. All right, then let's go in and do the same thing for rate. I like to put all of my stuff, my constants, at the top of the program. So we'll have min rate, and we'll set that equal to 1.0, so 1%. And let's put in a max rate. You don't see that anymore, but we'll put in 10.0. Finally, for our years, we'll say const. We'll say that the minimum number of years that you can put this in for is 5, and the maximum number of years, I'm just making all this up, is going to be equal to 25. So you could change this anyway if you are so inclined. So here, while is not rate, again, or rate is less than min rate, or rate is greater than max rate. All right, so those are fixed. And finally, we'll do the same thing here for years. So, or years is less than min years, or years is greater than max years. All right, that's all I've changed. First, let's make sure we didn't break anything. So file, save all. All right, and then we come back in here, whoops, to our HTML file. Come on. There we go. And we'll run the program, and we'll just accept the defaults again. All right, and it's still working. That's good. Okay, now let's make one more change to it, because right now we run it, we display everything, and boom, we're done. All right, well, what if we want to run it again? Okay, so let's do that. So we'll come up here, we'll add two more variables. We'll do, not a const, we'll make a let again, and we'll set that equal to y, and we'll let first char, like I did before, we'll set that equal to the empty string. And then down here, we'll do this. We'll say, again, equal, just a prompt, and I'll say, and we'll tell you to enter in a y or an n. But again, sometimes people don't read that when you say it. So we will put in here a y for our default. All right. And then we'll say, again, equals, again, dot to uppercase. And then finally, what am I missing here? Again. Oh, that should be there. There we go. And then finally, we'll say first char equals, again, dot char at 0. And we'll say, see. Well, we're resetting everything up here. So let's do this. We'll make a Boolean variable so you can see that. We'll call this run program again. Okay. And we're going to say while run program again is true, so we better declare a variable called run program again. And we'll set it equal to true. So the first time through, it'll run this. All right. Then I'm going to grab everything we've got in here, and I'm going to tab it over once. All right. Now, while equal first char at, again, dot char at 0, expected to, oh, okay. So we're going to come down here and say if first char not equal to a y, that means we're done. So if that's the case, we're going to say run program again equal false, which should get us out of here. And we need our ending curly brace at the end. All right. And that should be everything. Now let's take a look at what we've done. So let me do a save all and let's run the program again. It's easier to run it and show you what's going on. So we'll use the defaults. All right. And now we'll say no. And it ran it twice. Now we'd have to work with that a little bit, but it's in there twice because we told it to run twice, just so you see this. All right, just so I prove it to you because I did that so fast. Well, let's run it one more time here. We'll run it one more time. We'll put in different numbers. First of all, if I run it and I put in something that's invalid, it keeps asking me to do it, which is good. Our minimum investment was $1,000, so let's put in 999.99, which means that should fail, and it does. Let's do 1,000,001 cent. That should fail, and it does. So let's say, I don't know, we said a minimum was $1,000, so let's try $10,000. Okay, now it asks for the interest rate. The minimum was 1, the maximum was 10. All right, so for here, since the minimum is 1, let's put in a 0, and it doesn't take it. The maximum was 10, we'll put in 11, and it doesn't take it. All right, so we'll put in here, let's say 5%. And then our number of years, our minimum was 5, so let's try 4, and it doesn't take it. Our maximum was 25, so we'll try 26, and it doesn't take it. So let's put in here 15 years. All right, and it does ask if we want to run the program again. I'm just going to say no. So there we have it, $10,000. All right, 5 years, 15 or 5%, 15 years. All right. So what we have done in here, and you didn't have to do any of this, or I didn't have to do any of this, but I came back in here and I added 6 constants, all right, to try to bring some order to the program. Again, as you can see, the minimum investment was 1,000. The maximum investment was 10,000. I'm sorry, 1 million. The minimum interest rate was 1%. The maximum was 10%. All right. The minimum years for this was 5, and the maximum years was 25. In addition, we added 2 more things. All right. 3 more things. Again, which allowed us to run the program again first char, which is the first letter of, again, made uppercase, and then we added a Boolean. This isn't a loop control variable. You could call this more a program control variable. This is telling us to continue to run the program as long as run program again is equal to true. And we set it to true up there, so a next output. Then we came in here and we changed what we had in our do while loop. The only thing we had previously was we were checking for it non-numeric. Now we're making sure that it's also greater than or equal to 1,000 and less than or equal to 1,000,000. Then we did a similar type of thing, all right, for our interest rate. And finally, we did a similar type of thing for the number of years. Then we figured out our future value. We printed it all out using template literals. All right. Then we asked the user if they wanted to run the program again. And if they did, okay, if they did not, so if they put in anything other than a first character of Y, we stop the program run. All right. So that's that one. And with you, Grant, you don't even have to answer this, but I'm taking for granted this is a lot of review for you, and that's why you're not asking questions. Like I said, you don't even have to comment on that.
No,
So,
yeah, but thank you. It is really helpful, honestly. This is stuff that took me a long time last semester, so the review's
okay,
nice.
all right. Well, that's good then. Okay, then finally, and let me just grab all that. Oops, I gotta say no here. No. There we go. All right, so I'm gonna stop that run and go back into here. All right, so that's that one. And then finally, we've got an enhanced test score application. What that will allow us to do is we can put in as many scores as we want. And once we enter -1, -1 is also referred to as a sentinel value, Sentinel. Remember the old TV shows where somebody would say, Hall 2 goes there. That was the sentinel. Well, this sentinel value is going to show us when we want to finish the program. So what this one does, as you can see in here, we can have as many scores as we want. And at the end, now they've got 4 scores, so they are adding the 4 scores up and dividing by 4. All right. So you'll notice, unlike what we had before, all right, unlike what we had before, we don't have, all right, we don't have a score 1, a score 2, and a score 3. That would make no sense right now because we don't know in advance how many scores we're going to have. All right. So now all they're checking in here is greater than or equal to 0 and less than or equal to 100. All right. Otherwise, if it's -1, all right, if it's not equal to -1, you put in something invalid. That's not a terrible test, but we'll modify that a little bit to check for not a number, and we'll take the 0 and the 100 and we'll make them into constants. All right. And we want to do this while the score is not equal to -1. Notice, once we do this, once we put in -1 for a score, okay, we will fall out of the loop. Then, all right, we have been adding the total all the way across here and the count. So total is, if we entered 3 test scores, 40, 60, and 80, total would be 40 plus 60 plus 80, or 180, and count would be how many test scores we took. That would be 3. So then we come in and do the average and print that out. All right, they're doing a document.write, which is fine. We could use an alert. It really doesn't matter. They're using a document.write so that they can use a template literal in here. I showed you yesterday that the template literal doesn't appear to work when you're using an alert statement. All right. So let's bring this one up. In fact, before we do, we'll do what we have been doing. And that is, I'm going to go into the test scores and do exactly what I have been doing. And that is make a CSS folder, make a JS folder, move my CSS file into my CSS folder, move my JS file into my JS folder. Since I don't trust myself, double check. There's the CSS. There's the JS. All right, I've already got this open in here, but I'm going to close it and reopen it right now with hopefully the changes made. So open it with code. There we have in JS, we've got our test scores JS. Come in here, and as I have been doing, change this to give it the right path, change this to give it the right path. All right. I'll keep that up here, but I want to open up my JavaScript file. So I don't like hard coding values like this in. If we had another test, maybe just for up, you got 5 points. Even if you took the test and got nothing right, you got a 5. Or maybe it's a quiz and it's worth 50 points. So I'm going to come in here and use constants at the top. So I'm going to say const min score equals 0 and const max score equals 100. And I'm going to immediately save. And when I do a file save, all the semicolons are going away. All right. So I want to change this, and I'm going to say while score is, now notice what we're doing. What we checked before was we checked for things that were out of range. Now we're checking, and we're only doing this if this is within range. When you check for things that are out of range, you use typically an or statement. When you check for things that are in range like this, you use an and statement, which is what we're using here. And I am going to change this because we're not going to use 0 anymore. We're going to use min score. And this one, and I'm sure that probably it'll go down to just one set of parentheses when I get done. This will be max score. Like I said, as soon as I save, oh, it kept them both. Well, let's see. Oh, because I wouldn't need my other one here. There. Now let's see what happens when I save. Yeah. All right. That's one thing I don't like about having this prettier on is it's funny because I had one student many years ago. He said, he said, I call you the parenthesis fairy because you just sprinkle parentheses all over the place. Okay. All right. Let's also make a change here. Instead of total equals total plus score, let's say total plus equals score. Okay. And we'll use that combined assignment operator. All right. And then we're going to write the score. We can say if it's not -1, well, let's make that a constant too. And we'll call this stop val or stop value. We'll make that -1. All right. So not equal to stop value here and here. All right. So then we'll calculate it. There's other changes that we could make in here. Okay. Now this one, I've done it a couple times, so we won't let this one run again and again and again by putting in like we did before. We could do all that stuff. I'm not going to. Okay. All right. So let's just save everything and let's come back here and run it. Make sure we didn't break anything. Now, when you're testing this, especially when you're testing it for the first time, come up with something that's real simple. So 10, 20, 30, and we'll make 40. Okay, so 40 and 30 is 70, and 20 20 is 90, and 10 is 100. All right, so I'll put a -1 in here. 10, 20, 30, 40, the average is 25. It appears as though everything is working. All right, we can refresh our page and do it again. If I put in something that's now out of range, so -3, all right, now something's wrong. So you can see that. Average score is NaN. Now, technically, there isn't anything wrong. The thing is doing what we told it to do. Because notice what it said in here. If it's within here, use it. Otherwise, if it's not stop value, we just are doing an alert. Well, that's kind of stupid to do. All right, so there's other things that we could do in here. We could just skip it. All right, so if you put in something that was wrong, all right, then what we could do is just nothing. Now, if we did that, all right, we'd probably have to make some other changes in here. So if it was valid, we would do that. Otherwise, we're just not going to do anything with it. All right, I don't know if this would work or not, but let's just try to comment this out. All right, and see what that does. So file, save all. It may not work the way I think it's going to work. So let's do the same thing we did before. So let's put in here -2. All right, and it says when we end, let's again put in 10 and 20 and 347, whatever, and -1. And that looks like it worked because it only accepted the 2 valid scores. All right. Now we could, I think they did that in here. Maybe I just hit enter too fast. I don't know. We could come up with an error message if we wanted to, but I think that what we're doing right now, at least in my humble opinion, is sufficient. All right. In fact, let's just to be complete here, let's come back and do 2 more things, and then we're going to take another break. So I'm going to come in here, and as we've been doing, I'm going to let again equal yes. And I'm going to let first char, and there's nothing special about these names. All right. And then let run program again. We'll set that equal to true. All right. So I'm going to put the whole thing. So I'm going to have another loop in here. So while, and again, remember, I can say run program again equal true, or I can just say while run program again. They do the same thing. So put that in there. Let me get rid of my ending curly. Go way down to the bottom here and move everything over. Myself some room. All right. There'll be my ending curly. And just as we did before, we'll come in here and say, okay, do you want to do this again? Okay. So it was again equal run program again. Well, technically, this doesn't make a lot of sense to do it now. All right. And I could do this again, but technically it doesn't make sense. All right. What do I mean? Well, we're already telling it to stop here, so we can enter as many grades in as we want. So I am going to get rid of this. We're not going to use this. All right. And I'm just going to come down here and keep it the way that it was. All right. Make sure I didn't break anything. So I'm going to run it one last time. We'll put in 10, 20, and 30, and then a -1, and it should give me 20, and it does. All right, so that's the first 3. Now we're going to take a break, but just so you know, right before we do, let me do a save on here and close this. All right, then after the break, there's one more thing that we have to do. All right, so come on. Oh boy, I must have closed that. Great. So we did look at the enhanced, if you'd call it that, test scores app. All right. But what we're going to do after the break is we're going to look at something that's new that's known as an array. Okay, it is 10:07 right now. Let's take 13 minutes and come back at 10:20. We'll be done by 11 o'clock. All right, so please come back at, like I said, 10:20. All right, it is 10:20, so I'm going to start back up again. And sorry for Grant and anybody else watching this if I'm telling some of the same analogies or stories that I've told in the past, but we're going to talk about arrays right now. And whenever I think of arrays, I always think of the first time I ever took a class in college that was in a big lecture hall. And it's important for two or three reasons. And the first one is I went in there the first day of class, and there were 300 people in there in this lecture hall. There were two windows at the back. They weren't open. And after class started, the they shut the doors, and it got really hot in there really fast, and I fell asleep. And when I did, I was on an end and I dropped my pencil, and of course it rolled all the way up to the front by the instructors, so they made him wake me up. And he tried to make fun of me and maybe embarrass me. Maybe he didn't. I ended up liking the class and the instructor, but I said, if you'd get some frickin' windows in here that worked, or you'd open the door, I said it wouldn't be so damn hot. And then he laughed a little bit and everything was fine. But the point is this: imagine that it was the first day of class, okay? And I walked in there, got my seat along with the other 300 people, and we waited. 5 minutes went by, 10 minutes went by. And with the way it works in a four-year institution, if the instructor isn't there within 15 minutes, you can leave. So 5 minutes go by, 10 minutes go by, and we're all thinking, well, maybe we won't even have class today. So right at 10 minutes, somebody walks in who's not the instructor. All right. And they're not the instructor, but they're a teaching assistant. And they walk in with a humongous Ziploc bag full of Legos. And what they do is they say, hey, the teacher is going to be, the instructor is going to be a little bit late. He wants you to stick around, and here's a Lego for everybody. And some people have got, a Lego of one piece color size, and some have got another. But let's face it, what can you do with a Lego? Well, what we've been working with so far have been basically Legos. And what I mean is we've been working with variables that are known as scalar variables, SCALAR. They only hold one value. But imagine if we were working and playing with our Lego, and I ask the person next to me if I can have their Lego, and we start putting them all together, and pretty soon we've got all 300 of them, and we build something. All right. The reason I'm telling you that is that's not a scalar value. That's what's referred to, for lack of better words, each individual element that's in there would be a scalar value or an elementary data item. But together, we have what's called a data structure. And so what a data structure is, it's a collection of simple data items or scalar data items. All right. And an array is an example, all right, of a data structure. And it's the first one that we've looked at. Now, and this is important for Grant and everybody else in this class who had the AWD 1100 class, the C# class last semester. Arrays in JavaScript are special because the same array can hold both a number and a date and a Boolean and a string, etc. They can hold different kinds of values. All right. Now, when you set them up, okay, I'm going to go back, and this is the other thing. And again, I've given this example before. When I moved to St. Louis, not St. Louis, but Lake St. Louis, where I live now, when I moved there approximately 7.5 years ago, something like that. When I moved here 7 years ago, I don't know, it doesn't matter. But when I moved here, I moved into an apartment where I lived for 2 years. I had a daughter who was living in Illinois where we had our house, and she was still going to college then. All right. So my wife stayed back with my daughter, one of my daughters. I had another daughter who'd already moved to St. Charles here, and I had another daughter who just lived in another part of Illinois, and she still does. Well, the point is this. When I moved into an 8-family unit. All right. So imagine, I don't know what my neighbors' names were, but I was in unit number 1. And we're going to suppose that Jones was in 2, White was in 3, etc., like you see right here. So if somebody typically did this and they wrote, this wasn't my address, but if they put Jeff Scott, Lake St. Louis, Missouri, 63367, I probably would have gotten it because probably the mail person would have been smart enough to said, oh, Scott and Scott. All right. Now, to make it even better, they could have come in here and written like apartment number 1. All right. And that would have made it even better. But what if they wanted something for Sally Jones? If they put in number 1, I might get it, or number 2 might get it. So the more specific I can be, as long as I'm correct, the better the chance is that the right person will get the right mail. Why am I telling you this? Well, if you can imagine, if we looked at it this way, we could say, what do we have? We've got 8 units. So really unit 1 is equal to Scott. Unit 2 is equal to Jones. Unit 3 was equal to White. Unit 4 was equal to Smith. Unit 5 was equal to Brown. Unit 6 was equal to Black. Unit 7 was equal to Green. And finally, Unit 8 was equal to Kent. All right. So I could literally come in and create 8 variables here and do something like I could say, let unit 1 equal Scott, since it's a string, I could do this. And I am going to do this for all of them, not to waste my time or your time, but there's a reason that I'm going and doing all this right now. So when we get all done, as I will be in about 10 seconds or so, but when we get all done, as you guess, we have 8 different variables. And each one of those variables has a different value. All right. So what does this have to do with anything? Well, these are elementary data items. But what I could have done is I could have said this, let unit, in fact, I probably should have made those lowercase. So let unit instead of doing it like this, or again, where we have 8 different variables, I want to do this and make it 1 variable. All right. So I'm going to say let unit bracket equal, and I'm going to put in here, will take a second to do, so give me a second here and please be patient with me. All right. So Scott Jones, what happened there, but I think you're getting the idea. The big thing, the big takeaway from this as I finish this up is now we have 1 variable. And that 1 variable has whatever you want to call it, 8 different components to it. All right. That is an example of a data structure. Now, in this particular example, every single thing that's in this array, as you can see, they're all strings because they're all people's names, which is totally legitimate. But as I mentioned previously, when you are working in a language like JavaScript, they don't have to all be. You could have numbers mixed in here, you could have Booleans, etc. But the advantage is rather than having 8 different variables, all right, I now have one variable that's got 8 parts. Now, I do want to mention too, if I didn't want to do it like this, I could have come in here and just said let unit equal new array like that, and then come in and said unit, well, like we have right here. I'll have to make a couple changes, but just so you see it. So we don't want the word let in there at all. But when you work with arrays, and if we haven't mentioned this yet, you're going to hear this a lot in computer things you work in with computers. They start with a 0, not with a 1. All right. So rather here than saying unit 1, we'd say unit, and it's typically pronounced either unit index 0 or Unix subscript 0 or Unix or unit sub 0, 1, etc. But what I am showing you here are 2 different ways that we can declare an array. In the first example, we are declaring it, and at the same time that we are declaring it, we are initializing it. All right. In the second example, I'm declaring, an empty array, and I'm initializing it at a later time. All right. Now, so you can imagine, so why am I wasting all this time doing this? Well, once I moved, let's say that somebody else moved in and their name was Johnson. Now I can say unit 0 equals Johnson. All right. So what I'm showing you here is this is one collective variable. It has 8 parts to it, but it's one variable. These are 8 distinct variables. And before you say, well, fine, I get it. What is this buying me? All right. Well, let's talk about what this is buying you. So let's suppose for a second, I'm not going to go take the time to write them out, but let's suppose for a second that I've got a class and I've got 50 students in my class. All right. Now I want the grades for each student. All right. So I could say, let's say I create an array that's called grades. So I say let grades, and I'm just going to do it like this. In fact, I'm going to just say where I had this here, that should have said let right here. Okay. But I'm going to say let grades equal new array. Okay. Again, so far, who cares? What if I want to read in all 50 of those grades? If there are 50 of them, I give that a number. I can say 50 right here. All right. Now I can come in and I can write a nice little for loop that says for not int, I'm sorry. Let LCV, like we did before, equals 0. LCV less than 50 plus LCV. Now I can come in and say grades of that else of LCV. So for that particular grade is equal to parse int, prompt, please enter a grade. We'll give it a default value. Again, we'll give it 100. Let's say 88. All right. And we'll do it like that. Boom, boom. All right. So what did that buy me? I'm not worrying right now. I could come in here and check for is not a number. I could put a minimum grade and a maximum grade. That's not the point here. The point is this is going to run 50 times. And when I get done, I'm going to have something like this with grades 0 through grade 49. Maybe rather than grades, maybe I want to call this, because like maybe I want to call it students. And then this can be students as well. All right. Arrays are meant to work hand in hand with for loops. Not that you can't use them in a while or a do while, you can. All right. But this is pretty nice because now if I have 500 people, all I have to do is change that. All right. And now it'll handle 500 people. Okay. So with that kind of as a start or a little introduction, as they mentioned there, an array is each thing in the array, each value element. Arrays have a length. In the example I just showed you, the length was 50. You can use a new array constructor. I already showed you that because I said equal new array. All right. So when we look at the examples that are in here, all right, you can do this and say const array equals new array. You can put a number in there. You don't have to. You can leave it blank. That's again, unlike most other programming languages where you must put a number in there. And I forgot there's even a shortcut way of doing it that I didn't use. So we could have come in where we did all this. All right, this is totally fine, but let's do it the other way. So we can just say, let students equal bracket, bracket, and that works as well. All right, so there's a lot of different ways that you can come in here and do this. All right, there's a length property in here that you could use. So who cares? You should care. Because instead of saying 500 here, let's say I put a 500 in here. Let's just say I did put in 500. Now I can say students dot length. So if this changes from 500 to 1,000, I don't have to change this. All right, I only have to change the length in one place. All right. So there's a lot of nuggets, gold nuggets, so to speak, on this page here on 113 for you to start being able to understand how this is used. All right. And the description on the bottom, again, an array is designed to store one or more elements. The length of the array is the number of elements that are in the array. You can use the new keyword as I showed you, or you can just use an empty set of brackets. All right. To refer to the elements in the array, you start at element 0 is the first element, element 1 is the second element, etc. Now, how can that be kind of problematic? All right. Well, what if I wanted to do this? So I'm going to go and do another example here, and I'm going to say, let months equal bracket, bracket. Well, you typically don't want to say months 0 equal January. It's not that you couldn't. It looks wrong. All right. So what if I do this? What if I say, guess what? There's nothing in month 0, but in months 1, I make that equal to January. I make months 2 equal to February, etc. There's nothing wrong with doing that. All right. Totally fine to if I wanted to set it up I could say let months equal, and then I could come in here and put nothing in 0, and then whoops, sorry, and then January, February, March, etc. I'm not going to keep going. You get the idea. All right. So there's a lot of different ways that this can be done, and that's what I'm trying to show you here. All right. Now, another place where this is I'm going to say, for lack of better words, goofy. So again, all of you who had the class last semester, the C# class, this is different than C#. All right. If I come in here and I'm going to use the same example that I had before, this one. And notice I said here, let unit bracket equals this. You can all see that. Now, I come in here and let's say the person in unit 6, green right there, they move out. And a new person moves in. So I want to say unit 6 equal, let's say Clark moved in there. But when I put this in, I fat finger and I do this. Guess what? It's not an error. What happens is these are still all in there. Everything that you see would still be in there. If I did change 0 to Johnson, I'm going to get rid of that then. Okay. But 8 will be blank, 9 will be blank, 10 will be blank, 11 will be blank, all the way till you get to 66. All right. And that can just lead to weird errors because there's going to be, it's as though we had a unit with 67 in there, 0 to 66. All right. So weird stuff can potentially happen when you do this. All right. In this language, because again, it's a very forgiving language. They talk about using loops. I mentioned the for loop, which is the one usually used, but they're examples. There's nothing wrong with them. All right, nothing at all. All right. But I want to show you something that's kind of cool regarding this. All right. And that is this. Let's go look at that example we had before with, let's see, let's go grades one again. All right. So I'm gonna just, for right now, I'm just trying to be complete here. And all right, maybe after class, I'll go back and make it so I'll put in all the months. But let's pretend for a second here. I'm gonna just whip something up real quick. All right. So I'm gonna do a let grades equal, and I'm gonna just assume I'm gonna make it real simple. I have 10 people in the class. All right. And these are their grades. I'm making all this up. 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I've got these 10 people. All right. They're all in there. I don't have to put in their values. They're all in there. Okay. But who cares? I'm going to show you why you might want to care. Okay. So I'm going to come in here and I'm going to say this. I'm going to say let high grade. And we're going to assume that the highest grade you can get is a 100 and the lowest grade you can get is a 0. So I'm going to set high grade to -1. I know that might look weird. I'll explain it in a minute. And I'm going to let low grade, I'm going to set that equal to 101. Then I'm going to say in here let, and I'm going to put average, AVG grade, and I'm going to set that equal to a 0. Okay. So why should you care? Who cares? I'm going to show you right now why you might care. So I'm going to do a for loop, and I'm going to say for int LCV equals 0. LCV is less than grades dot length plus LCV. Now I'm going to come in here and I'm going to say if grades LCV, if it's less than our low grade, then grades LCV equal low grade. Just like that, I'm done with that part. Okay, except I need my ending curly brace. And then I'm gonna copy this, and I'm gonna just change this to if grades LCV is greater than high grade, then it becomes high grade. All right. And then I'm gonna just create a variable called sum. And it doesn't matter what I call that. I'm gonna make it 0. And then I'm going to say this: sum plus equals, all right, grades LCV, just like that, nothing else. Now, okay, now when I'm all done here, I can say average or average grade equals sum divided by grades dot length, just like that. Okay. And then I can come in here and I can do an alert or whatever, and I can say high grade, how about low grade equals, and then we'll say low grade. And then we will say after that, hopefully you get the idea. Okay. And I'll just put it in here and I'm going to copy it down 3 times. Then I'll say high grade equals high grade. And finally, AVG grade equals AVG grade. All right. Now, you may or may not right now already be able to appreciate the power of this. But again, imagine if I had 500 students, boom, by writing in 10 or 15 lines of code, I could get the high grade, I could get the low grade, I could get the sum of all my grades, I could get the average grade. If I wanted to, I could add the stuff we had worked with earlier, and I could put that big if statement that we had in there, and I could figure out the number of people who had A's, the number of people who had B's, the number of people who had C's, the number of people who had D's, and the number of people who had F's. So this is unbelievably powerful stuff that we're doing right now. All right. And the last thing about this before we look at their last program in here is they talk about a for in and a for of loop. They're just shortcuts so that the way that I just showed you with a regular for loop, you can write even less when you use these. Why would you want to? Because I've said this before. This is not a joke. It isn't funny. I don't know of anyone who ever told me I got into computer programming because I like to type. So when you look at this, this is the equivalent of what we wrote before for that thing when we put in the sum. But instead of saying for LCV, etc., all right, now we're creating a brand new variable right here called I. We're just making it up. You can call it hello, but then that has to be hello. And I do want to mention, because this is typically the most confusing thing to people, is reading this. And what the heck does that mean? LCV is a placeholder. If I have 10 students, the first time through, LCV is for grade 0. The second time through, it's for grade 1. The last time through, it's for grade 9. LCV is just a variable that is a placeholder, and that's all it is. That's it. There's nothing there is nothing at all special about it. Again, we could call it anything we wanted. All right. And, when I started this, all right. And again, maybe Grant has heard, and some of the rest of you have heard this story, but it's the truth. The first time I took a programming class, the guy told us he wanted us to be able to put in an array of 100 numbers and kind of do what we're doing here. Give us the highest number, the lowest number, the average number, etc. And they were all laughing about how easy it was. I kept thinking to myself, what the hell is an array? Because he never explained what it was. So when we got done with the class, and I didn't have an internet back then, so I went to the library and I looked up array and I found a math book. This is, like I said, just really, really powerful stuff. All right. We'll look at some for in examples. We'll maybe go back and rewrite something tomorrow when we're looking at that. So finally, the last thing that's in here is this test scores application that's redone with an array. So what's the difference? All right. The difference is when we're putting these scores in, we're putting them into an array called scores. All right. We're doing the same stuff we did before. All right. Notice if the length is greater than 0, all right, then we want to display everything. And we're still calculating the average, etc. All right. So I'm not going to do a lot of rewrite on this one. We could come in here just like we did before and make a min score and a max score. But I'm more concerned here with you understanding what's happening. So let's walk through it here. All right. As opposed to even bringing it up on screen. So we're declaring one variable that's called scores. And it's going to hold, if we put in 100 scores, the first one will be in scores 0 or scores sub 0. And the last one will be in scores 99 or scores sub 99. We are again setting score. There's a difference. Scores pluralized is the name of the array. Score singular is what that particular score was. So again, we can come back in here and we can make sure that it's between 1 and 100. All right. And we could do an is NaN check in here again. We could add more stuff to that. All right. Maybe if I get done with my afternoon class a little early today, maybe I'll go back and make some changes to this. But it's the same program. The difference is if we have 10 people in the class, rather than having 10 different scalar variables, we now have an array with a single variable with 10 elements in that variable. That's the key thing. All right. And that is it for the chapter. So like I said, I'll go back, and I didn't mean to shortchange this at all, but I did want to mention to you, and I wanted to be done by 11 o'clock. All right. And that is, okay, we've got short exercises and we've got extra exercises. One of them is the homework and one of them is the don't remember right now which is which. I don't care right now which is which. All right. But for chapters 1, 2, and 3, you have to do this. Number 1 says test an application and find an error. We can look at that one tomorrow. It's no biggie one way or the other. Chapter 2 says modify the test scores application. We probably have already done most of that, but we'll look at that one again tomorrow. All right, short 3 says enhance the future value application. Again, we probably have done that already, but we'll do that tomorrow. So I will, by this time tomorrow, you'll have these 3 done already. All right, then we'll go over to the extra exercises, and you'll notice that there's 1, 2, 3, 4, 5 of them. All right, and we will look at the first one, convert Fahrenheit to Celsius. All right, we will look at the second one, enhance the Fahrenheit to Celsius application. I'll let you do the third one on your own, convert number grades to letter grades. It shouldn't be hard because we'll have already looked at some of it in here. All right, then the sum of numbers, I'll let you do that one too. And we'll do this last one, that's probably the hardest one, the sales array. We'll do that one together. So what I'm telling you is you have 1, 2, 3, 4, 5, 6, 7, 8 of these that you're going to have due on Sunday, the 12th. Was it Sunday? No, I'm sorry. It's the 19th of March. Not even this Sunday. All right. So we will do out of these 7 or 8, we'll do 5 or 6 of them together, and I'll have you do the other couple yourselves. Now, if you're working on the other couple and you have problems, I'm more than happy to help you with those. All right? But I'm just taking for granted that if we do enough of these, we get in your mind what you have to do. Now, next, as I mentioned, we're going to do 4, 5, we're going to skip 6 for now, and 7. So when we get there, there'll be 1, 2, 3, 4 here that we have to do. And there will be 1, 2, 3, 4, 5 here that we'll have to do. We'll do again when we get to that point for every set of exercises we go through, we'll do at least one of each one of them together. I will still expect you to do those and turn them in. All right, but I will do them. I'm not going to save them and put them in a repository. I'm going to do them in front of you in class. And there are going to be times when I do them in front of you in class that, guess what? Here's a surprise. I'm going to screw up. I've actually got the answer key. I don't like to use that. I mean, if I can't do it myself without using a flaming answer key, I shouldn't be teaching it to begin with. All right. So I'll sit there and do them from scratch. Sometimes I'll make a mistake, not on purpose, but I will anyway. All right. So I'm going to clean this up a little bit. All right. And I'm going to add that. Right now, it actually is saved with the other stuff from on this JS Murach, JavaScript Murach that I've got. So this will be out there along with these other ones that we looked at today. In other words, today we looked at Chapter 3, and there's that cheat sheet I called it. It's all the stuff we've done today. We've redone the future value, the MPG, and the test scores. I'll make a couple modifications to the test scores array, and then I'll put this whole thing out there. All right. So again, it's already out there. There is a GitHub repo that's called JS Murach, and I'm just going to keep adding to it with every chapter. All right. So unless Grant, unless you have any questions, hopefully, like I said, it's making sense to everybody, not just people who've already had this, but all the newbies. And if you've got any questions, let me know. Any questions now, Grant?
Not at the moment. No, thank you.
Okay. All right. Thank you. Thanks for showing up as always. And I'll be back tomorrow to do some of these in class. Have a good day. I'll talk to you then.
Thanks, you too.